degree of freedom system could look like a lot of things. All right, it could look like a mass. It has two springs. And, let's just say that x1 moves in that direction, x2 moves in that direction. All right. So I've got 2 degrees of freedom because I have 2 independent axes that it can move along. I could also have a 2-degree of freedom system that looks like this. I got a spring, I have a mass. Let's say that x1 moves down, just like we've had before. Let's say that the other degree of freedom is kind of rotational. That maybe there's a better way to draw it. Make it flatter. X2, and that's other, that's got an other rotation. So I could still have a K1 here. That's my stiffness in my lateral direction. I could have a K2, and that's my stiffness in my rotational direction. That's a very practical 2-degree of freedom system. Again, because it has 2 independent coordinate systems. So that'll be a very good thing for you to understand, is that a 2-degree of freedom system has 2 independent coordinate systems. These systems are very good 2-degree of freedom systems, and actually they're probably very good examples for us to use, but they're a little bit complicated and hard to draw. So we're going to use a 2-degree of freedom system that looks like this. So we have one mass on a spring. And sorry, this is not underdamped. This is undamped. Undamped. There's a section. And then we have another mass, another spring, another mass. And of course, these are on some rollers and on some sort of fixity. That's x1. That's x2. Right. So there we've got our rollers and we've got our fixity. Okay. The important thing to remember here, it's not a 2-degree of freedom system because it has 2 masses. These are also very good 2-degree of freedom systems. It's a 2-degree of freedom system because it has 2 coordinate systems, x1 and x2. Granted, those coordinate systems are placed or facing in the same direction, but they start at different places, right? So 0 of x1 is not 0 of x2, and so we have a 2-degree of freedom system.